In this video we're going to use Python as a calculator one more time, but now to do something a bit more complicated. Let's say we want to work out the orbital speed of a spacecraft. Now the equation for that is this one over here, v equals root gm over r. So let's set up a Jupyter notebook for that. So we're still running Jupyter here. So let's go to this tab here. We're on the desktop. And let's create over here a new Python 3 notebook to do this. Now the first thing we're going to have to do is once again define our variables. But in this case this includes variables like the mass of the Earth or the gravitational constant. Gravitational constant is 6.67 by 10 to the minus 11, whereas the mass of the Earth is 10 to the 5 by 10 to the 24. So we're going to need scientific notation to write numbers that big and that small. Now the way you write scientific notation in Python, and in fact in most other programming languages, is like this. So G is equal to 6.67. Now times 10 to the minus 11. The way you write that is E minus 11. So the E means times 10 to the power of, and then minus 11. And for the mass of the Earth equals 5.97 E 24. And that means 5.97 times 10 to the power 24. So you don't actually spell out times 10 to the power of something, you just write E, whatever it is, positive or negative. And that's the way you do scientific notation in Python and other programming languages. Now we need the distance from the centre of the Earth, call that R. So we'll call it, say, 7,000 meters from the centre of the Earth. Okay, so that's defined our variables. We'll do Shift-Enter to run that cell. And now let's check that it's working. It's always good practice to check after every cell that it's done what you thought it was going to do. So we'll print G, M, R. Now notice Python is case sensitive. A capital G and a small g are not the same thing. So if I do that and Shift-Enter, it should work. But if I changed it, say, to have a small g in there, we get an error. Small g is not defined. That's because lowercase g and capital G are not the same thing at all. They're unrelated as far as Python is concerned. So let's get it back to a big G, and that's working. Okay, so that's how we handle scientific notation. Our equation, however, has a square root in it. How do we do square roots? Well, for that we're going to have to understand Python libraries. A library in Python is an add-on collection of functionality. There are literally thousands of libraries that various people have written for Python. You can write them yourselves. There are libraries for analysing astronomical data. There is a library for doing artificial intelligence work. There are libraries for data processing. There are libraries for writing web pages. You name it, there's a library for it. Now the way we use libraries is, first of all, you have to import them into Python. That's usually done at the stop of the program. It has to be done before you use the library. So we're going to need a new cell up the top here. So I'm going to click at the top cell and then insert cell above. And then I'm going to type import. I'm going to use the math library. And I'll Shift-Enter on that cell. And now down here we can have our equation. We have the equation as velocity equals the square root. And the way you do square root is, in the math library there's a whole bunch of functions. You can check out the link provided in the written notes and see what they all are. There are things like square root, exponent, sine, cos, tan, arcsine, and so on. Almost any mathematical function you want is in there. And the way you call a function that's in a package is you type the name of the package dot the name of the function, which in this case is square root. Now we want our equation gm over r, so it's g times m over r. And let's print the answer to make sure it's working. Okay, so let's Shift-Enter on that one. And it's working. It's going pretty fast. Now r of 7,000 is much too short. That's 7,000 meters from the centre of the Earth, which is 7 kilometers, which is deep underground. There should be another 3 zeros in there. So shift enter on that one. If you change something here, it doesn't take effect unless you run that cell again. Now if we print it here, it's looking better. And that's dropped to only 7.5 kilometers per second, which is more reasonable, 7,500 meters per second, which is still bloody fast, but more reasonable. Now, as usual, let's tidy that up. So let's put in speed equals, again in quotes, because that's a string. We don't want to try and find a variable called speed. And we'll go up the top and add, insert a cell above, change it to markdown format. And we'll type some words in here so that when we come back to this we know what it does. Shift enter on that cell. Okay, so there we have an orbital speed calculator, and you can change your distance here. Let's say we go 8,000 kilometers from the centre of the Earth. Shift enter that one, and then shift enter down here, and the speed has dropped as you go further out. I also want to show you now how we save and shut this down. So we've saved it before, but let's change the name. Orbit speed calculator. And we can see if we go over here, we now have this one also running. You can see the ball height calculation we did earlier is still running even after 37 minutes. Even if you kill the tab, let's say I got rid of the tab here, it would still be running. So if you want to shut it down, you have to go to File, Close and Halt. That gets rid of the tab as well, and now you see the file is still saved, but it's no longer running.